Section 6.8, example 5 on page 492 and 493, we have problem 4 uses a transformation of y equals the cube root of x. The function f of x equals the cube root of x is the inverse of g of x equals x cubed. Unlike y equals the square root of x, the domain and range of f of x equals the cube root of x are all real numbers. The patterns for graphing square root functions apply to other radical functions. Example 5 says, what is the graph of y equals 2 times the cube root of x plus 1 minus 4? I've attempted to sketch the parent function y equals the cube root of x. It should look a little more smooth, but that's the general idea. The first step to graphing y equals 2 times the cube root of x plus 1 minus 4 is to identify points on the parent function. We have the points 0, 0, 1, 1, and negative 1, negative 1, because the parent function is the cube root of x. The cube root of 0 is 0, the cube root of 1 is 1, and the cube root of negative 1 is negative 1. Step 2 is to multiply the y-coordinates of the points by 2, resulting in a vertical stretch of the graph by a factor of 2. The y-coordinate here is 0, and 0 times 2 is still 0, so this point does not move. The y-coordinate here is 1, and 1 times 2 gives us 2, so we get the point 1, 2. The y-coordinate here is negative 1, and negative 1 times 2 is negative 2, so we get the point negative 1, negative 2. The final step is to translate the graph 1 unit to the left, since h is negative 1. We had a plus 1 on the inside of the radical, which means h is negative 1, and 4 units down because we had a minus 4 on the outside of the radical, which means k is negative 4. If we take the point 1, 2 and shift it 1 to the left and 4 down, we get the point 0, negative 2. If we shift the point 0, 0, 1 to the left and 4 down, we get the point negative 1, negative 4. The point negative 1, negative 2 shifted doesn't quite fit on this graph, but it is shown on the following slides. So the following slides have all this work written out, and then you can see the final graph of y equals 2 times the cube root of x plus 1 minus 4. Now I would like you to try number 9. Graph each function y equals the negative cube root of x plus 3 minus 1.